Let's start labeling our diagram too. Why don't we do ABC scalene? That means, what's that again? Scalene. That means it has how many sides?
Two sides.
Does it have two?
Wait, no. 0.
Oh boy, that's isosceles. 0, no sides congruent, and no angles congruent. Okay, so keep that in mind. That we are given that ABC is scalene, so that means it has no sides or angles congruent. Keep that in mind. AE and CD are altitudes. We talked about this yesterday, and that's a vocab word in this unit. What do altitudes do? So I can label my diagram with something here. Altitudes do what? Shoom. Let's go back to that crew over there, Jack. Darn right they do. So everyone, AE is creating a right angle, and so is CD. That is creating a right angle. Good. Next question, how do I know this has to be done indirectly? What up here in this proof says you better do this a different way? Sam, how do I know I have to do this a different way?
It's not congruent.
Not congruent. Prove AE not congruent to CD. All right, so I got to do it indirectly. So that means I need an assumption now. What are we assuming is true now? What are we going to assume in this diagram is true? Let's go. Try that again. There we go. Camilla, what are we going to say is true? Good. Perfect. You say the opposite of the proof statement is true. I don't know. How do you want to? I don't know how to. It's going to get messy, right? I guess here. A little messy, but just know that you don't have to mark it either if you don't want it. If you don't remember it's congruent, that's fine. All right. Looking good so far, everybody. Looking good. All right. Usually, we need to have a contradiction, right? We need to contradict something. And what the proofs I showed you yesterday, it was pretty easy to figure out which one we were going to contradict. It was always the one that was not equal. That was always the given we were going to contradict. You go to this proof today, you'll notice there is no not equal to in the givens. But I'm still going to have to try to contradict one of them. So either we contradict its scalene or we contradict that they're altitudes. One's a little bit easier than the other. What's scalene mean again? No equal sides or equal angles. So if we can do what about triangle ABC, we contradicted that it was scalene. What's scalene again? No equal sides or angles. So if you guys can prove it does have equal sides or angles, that's a contradiction. All good with our plan. Can you show me that triangle ABC has two congruent sides or two congruent angles because it won't be scalene anymore? Can we do that? Take a look at the diagram a little bit because I don't want to give it away. See what we have already. This is fun. Is there a way I can get two congruent sides or two congruent angles here? Guys, how do we get sides and angles congruent? By proving what congruent first? Triangle. We always go through the triangles first, don't we? So we could say CPCTC. Do you see two overlapping triangles in that diagram that if I prove congruent, I could prove the sides of ABC congruent? I want to prove the sides congruent. Do you see two overlapping triangles up there? See them? Do you see? Highlight them then if you see them. Highlight two overlapping triangles that if we prove congruent would show two sides of triangle ABC congruent. Because I'm nervous here. Some people will do one pair, some people do another pair, but only one pair will get us sides Only one pair will get us sides in triangle ABC. Okay, here's what I'm seeing from some of you right now. A lot of people are highlighting this triangle with this one. If I say CPCTC, will that give me a pair of sides? I need AB congruent to BC. Will that give me AB congruent to BC with those two triangles? Will it get me AB and BC? No, it won't, right? It'll get me angles, but I'm trying to go for AB being congruent to BC. And as everyone see, if you try to prove those triangles congruent, they don't contain AB and BC. I need two triangles that contain AB and BC. So, yep, I know we got to go into a different pair, which will be now these pair right here. Everyone see that pair of overlapping triangles? BDC with BEA. Okay, we're going to go with that pair. That'll get me sides. That will get me sides. And honestly, I think they're a little easier to prove congruent than the pair I just showed you. Okay, I think they're a little easier to prove congruent. All right, let's get them congruent so you guys can start working on your own here. Your assumption, you now have a pair of sides. Jack told us the altitudes form right angles. In my diagram it did, but it did not form right angles in my statements, did it? All right, so name the two angles in the triangles we're trying to prove congruent that are right angles. Where are the two right angles in the two triangles we're proving congruent here? Here we go. Leo, where are they? The two right angles. Only two are in the triangles I'm proving congruent, so those are the two I want.
Angle BDC.
Okay, I'll start there. Angle BDC and
BEA.
BEA. Yep, good job. Are right angles. We talked yesterday. I don't have perpendicular lines here. I have what instead? What made me put the right angles there? Not perpendicular lines this time, but Jack, what made you put the right angle there? A definition of an altitude. You tell me they're right angles right after. What do we always say about those right angles, Amelia? Awesome. Okay, there's a pair of angles. If we're trying to prove these congruent, I need one more pair then. We always need three pair of parts. I only have two pair. Keep searching right now. Keep searching. Anybody see anything on their own? Because I've kind of used the assumption and the altitude in the givens already. So is there anything you can see on your own between those two triangles that I can say? Anything on your own here? Do we see anything? Charlotte, see anything? Anything that's maybe shared between the two triangles? A side or an angle that is shared between both of them. Angle B is shared by both. There you go. Angle B congruent to itself, reflexive. Got it? And now it's a matter of, is it angle side angle or angle side, right? I'll get to that in a second. You guys can think about that as we are writing the congruent statement up here. First up, name one of the triangles for me. Name one of the triangles that we're proving congruent here. Here we go. Next up, Noah, name one of the triangles. Triangle AEB. Okay, I got it. Who's going to match them? Make sure I can match them first too, before I call on somebody. If I go AEB, I got it now. How do you name the other triangle then? How do we name the other triangle? Ariella? CDB, darn right. And now here we go, method time. Again, if anybody your diagram's all highlighted and marked up. Draw one of them out. If I draw out triangle BDC, I had a right angle here. Angle B was reflexive, and DC was a congruent side. Hopefully that makes it a little easier on the method now. And what is the method why they're congruent? Keep it going here, Eli. Thank you. Angle, angle, side. Look, what was the purpose of proving the triangle's congruent? So we could get a pair of sides. All right. Now what I want you to do, hey, name a pair of sides that are going to be congruent by CPCTC. That does not make this triangle scalene anymore. Okay, name a pair of sides that are contained in these two triangles, because that's why we proved them congruent. That'll now make that triangle not scalene. What two sides are now congruent? That won't make it scalene anymore. Esme? BA congruent to BC. Yes, indeed. And now everybody see the problem. It can't be scalene when it has two sides congruent. That's impossible. Right? That is called begins with a C, ends in contradiction. Contradiction. Good, Connor. You picked that up quick. Yeah. If that's false, so is my assumption. My assumption is false. So that means AE not congruent to CD. Once you have that contradiction, you are done with the proof. You just have to write the proof statement. Once you have the contradiction of a given, you are done. You just have to write the proof statement, and our little assumption led to a contradiction. All right. I just want to make sure there's a place where you guys can check your work here as you move on by yourself now. Unit 5, homework answers. Yep, indirect proofs, day 2. Okay. All right, here's what I want you to do. You do a proof, you call me over. All right, I'd rather work with you individually than you guys go into the answer key and writing down just anything that's incorrect and fixing it. All right, I'd rather work with you individually. So call me over once a proof is done. I'll give you the okay, and then you move on to the next one. All right, I want this done individually today. All right, so please do not work in any groups. Not that you guys can't handle it, but we got to be able to do these individually. So call me over when you're ready.